Hello grade 12s and welcome back to another video. In this video, we're going to discuss very briefly safety considerations in everyday life in terms of change in momentum and net force, of course. And we're going to look at how you can interpret graphs of net force versus change in time. So if we take a look at very old cars, right? So the old design of cars versus the new design. We see that in the new design, we have what we call crumple zones, normally at the front and at the back of the car. And these crumple zones are there to reduce the impact and therefore the injury that passengers inside of the car will experience. Another example of things that we do to avoid impact or injury is when a cricket player catches a ball, they take their hands and they move them backwards. Right. So the reason for this is as follows. We're very aware now of the impulse momentum theorem, and we know that change in momentum is equal to the net force multiplied by change in time. So, if two objects undergo the same change in momentum, but for the one object, like our modern day cars, we can increase the time. If we have that the change in momentum is constant and we increase the time, then of course it means that the net force is going to decrease. The reason we have crumple zones is to decrease the net force that passengers inside the car will experience, even though the car will undergo the same change in momentum. It is for this reason as well that cricket players move their hands backwards when catching a ball. What they are doing is they're increasing the time of impact that the net force that they experience is smaller than it would be if they did not move their hand backwards. If they just kept their hand in a fixed position, what would happen is that the time would decrease, and this would result in a large net force being applied on their hands. Right? And this, of course, is taking into consideration that the change in momentum is going to be the same in both cases. So, in summary, we say the same change in momentum over a longer period of time results in a smaller net force and therefore less injury or impact. Grade 12, this is a very important statement, and it's going to help you to answer questions that will ask you about safety considerations in terms of change in momentum and the net force. Now, sometimes instead of giving you a paragraph of information to interpret, to find values, etc., we may give you a graph instead. And it is very important that you know how to use these graphs to answer the questions that are given to you. So, displayed to your screen is a graph of net force versus time. When an object, for example a ball, is thrown into your hand, what you will experience is that at first the force is very, very small, but then it starts to increase. You'll then experience a maximum force, and then the force will slowly start to decrease once again. This is why the graph looks the way it does. We normally speak about the average net force that is being applied to your hand, but if you see a graph like this one displayed to your screen, it is giving you a truer reflection of what you would experience. Now, of course, looking at this graph, at the peak of the graph, we see the maximum force experienced during the collision. What is more important than finding this maximum force is your ability to make use of the area under the graph. If we look at the area underneath this specific graph, we know that the area is going to equal to the area of a triangle, which is half base times height. But in this case, what is the base? Well, the base is time, so let's go and plug time into this equation. And what is the height? Well, the height is the net force. So over here, I'm going to plug in F net. If we move these values around, yes, there is a half in front of this. The half is just because the area looks or is a triangle, so don't allow that to confuse you. But we actually have the net force multiplied by the time or change in time. Where else have you seen this? Net force multiplied by time. Well, this is actually how we calculate impulse. So grade 12, what I'm trying to tell you is, if ever you see a graph of this kind and you are asked to calculate the impulse experienced, then please, it is important that you calculate the area underneath the graph. So these are the types of questions you may find. Sometimes in other questions you may need to make use of the gradient. But when it comes to the graph or a graph of net force versus time, this is how you can use it in order to calculate impulse. In the exam practice videos, we will look at an actual past paper question that involves a graph. But for now, we've reached the end of this video. In the next video, we're going to take a look at the principle of conservation of linear momentum.